All right, guys, we are moving into the second part of chapter 2. I'm really excited about this. I like graphing. That's where we're going. How are we going to graph these polynomial functions? We've done linear stuff. That's like a review of Algebra 1. We've done quadratics, right? Parabolas. But what happens when we go past that? Okay? So there's this worksheet that I put together in class that basically has you take a look at, how can you keep track of, and it's in the classroom, so you'll see it. On the left side, we go through and we move up. Let me almost like write what it's going to look like. I say, on the left side, we go, what is the degree? Right. So what does a graph look like when it's to the first, to the second, to the third, to the fourth, and it goes all the way up to 8? And then I say, what is a little sketch of that? We're going to use this website called Desmos. Okay, I really, really encourage you to head to Desmos and punch in little examples. I'll show you what I mean in a second. In that sketch, you want to ask yourself, how many maximums or minimums were there? Basically, points of inflection, right? Points where you go like this, right? That's like a local maximum, something like that, okay? And then the last thing I ask is, what's going on with the end behavior? And what I mean by that is, we remember doing like concave up, concave down, like, does it look like this? Does it look like this? What's it look like? Like, in what direction are we ending? Okay? So like I said, this is a class activity where it's an exploration. So what I start with is I will literally say, like, let's come up with an example as a class. So something like y equals 2x plus 1 or something. That would be like a first degree, right? A second degree example could be something like y equals 2x squared plus 1. Moving to the third degree could be something like y equals 2x cubed plus 3x plus 5. Right? Going to the fourth degree, we could do like y equals 2x to the fourth minus x squared plus 3x plus 5, right? I am making this up randomly. And as a class, we do the same thing. I will ask you guys, help me put this together. Because the goal is, let's observe a pattern. I don't want to tell you what's happening. Let's throw some stuff together. Let's punch it into Desmos, and what does it look like? And what we find is linear looks like this. Quadratic looks like this. And we're not surprised by that. We've seen that before. And then our cubic should probably look something like this. And our quadratic will probably look, or sorry, our quartic probably look something like this. So we go from having 0 maximums or minimums, some straight line, to 1, to 2, to 3. And I go from having endpoints that are kind of like alternating, like one's going up, one's going down, to same, back to alternating, back to same. All right? And I would encourage you from the bottom of my heart, please, that worksheet is attached with this assignment. Try and come up with your own examples as you're filling it out, right? The coolest thing is to be able to be like, I came up with these, and I'm noticing the same things that Mr. Card is saying, proving that I'm not making this stuff up, right? And then I say, can we derive from that some ideas here, right? I like, when I can, to put you in the situation of being a mathematician, which is you're observing patterns, and what do you see? And it was great. We did it in class today. And I had a student who was spot on and being like, well, what I'm noticing is it kind of seems like if the degree is odd, then I know that the endpoints are always alternating. And if the degree is even, then it kind of seems like the endpoints are always going in the same direction. I said, you are absolutely correct. You are being a mathematician right now. You're observing a pattern and you're saying, can I conclude a rule from it? Okay, we can see obviously there's differences here on this slide between like, well, what if there's, what does the leading coefficient do, right? Concave up, positive, concave down. So obviously, which way are you alternating? Are you moving down as you head towards infinity, right? We say here heading towards infinity. You might colloquially, see, I'm not an English teacher, but casually you might think like, as I move to the left, right? As I move towards negative infinity. Am I going down or am I going up? That has to do with that leading coefficient. And then when in terms of like how many times you inflect, like a maximum, we'll talk about why it doesn't necessarily mean that you'll inflect that many times later. But that at a maximum, your number of turns is determined by the degree minus 1, right? A straight line is the first degree and it never turns. So I would look at this and say 1, 2, 3, 4. Oh, this thing is 100% something to the 5th power because it has 1, 2, 3, 4 turns. And then I think to myself, oh, 5th power, that's odd. And sure enough, does it have alternating directions on those endpoints? It sure does. So we are not at a point yet where I'm actually making you take something like this and start graphing it. We're not there yet. We're going to get there soon. Okay, but right now I just want you to be able to recognize that if I say, hey, you have 3x to the 6th, can you tell me something about, let's say, the end behavior? And you would say, of course, Mr. Card, it's going to be going in the same direction. All right, that's where I want you guys to be now. All right, and I would encourage you, head to something like Desmos.com and start just throwing in examples. It's the best way to get good at this is immerse yourself in as many examples so you start seeing, yeah, you know, I can kind of manipulate. All right, here's 2x to the 5th. What if I did 3x to the 5th? What if I did 4x to the 5th? And see, all right, when I do that, it doesn't necessarily change actually the end behavior, things like that. And I'll end the video right there.